Hello, everyone. I'm Tang Shenping. Today, I'm going to walk you through this lesson, and I'm excited to be learning with all of you. Last class, we introduced Modbus. This time, we'll dive into a detailed description of the Modbus protocol. 1. Modbus standard or bus supports TCP, IP over Ethernet. Asynchronous serial communication includes EIA-TIA 232E, EIA 422, EIA-TIA 485A, fiber optics, radio frequency, and Modbus Plus. Gateways enable communication between different types of buses or networks using the Modbus protocol. As shown in the Modbus communication network architecture diagram, this is the structure of a Modbus communication network. PLCs, I/O devices that support Modbus, and HMIs can connect to Modbus communication via Modbus Plus, RS-232, RS-485, TCP, IP, and other methods. 2. Clients and servers in Modbus. A Modbus client is a device or software application that communicates with a Modbus server. Its job is to send requests to the Modbus server to get data or carry out control actions. For example, imagine a microcontroller connected to a sensor over a wired network using Modbus to read the sensor's data. In this setup, the microcontroller is the client and the sensor is the server. Specifically, a Modbus client can do these things. 1. Data reading. It can ask the Modbus server for real-time data, like sensor readings or device status. Data writing. It can send requests to the Modbus server to update device settings, configurations, or control actions. 2. Device control. It can send commands to operate devices connected to the Modbus server, like starting or stopping a device or adjusting its settings. 3. Monitoring and diagnostics. It can leverage real-time data and device status to conduct monitoring and diagnostics, thereby ensuring system stability and pinpointing potential issues. 4. Integration and automation. It can link Modbus communication with other systems to automate control, collect data, and process it, which helps make production more efficient and the system more reliable. 3. PDU and ADU. Modbus defines the Application Data Unit, ADU, also known as a Modbus frame, which contains a Protocol Data Unit, PDU. The maximum size of a PDU is 253 bytes. For ADUs, the maximum size is 256 bytes over RS-232, RS-485 networks, and 260 bytes over TCP. In terms of data encoding, Modbus uses big-endian representation for addresses and data fields. So, for a 16-bit value, the most significant byte is sent first. For example, if a 16-bit register holds the value 0 hex 1234, the byte 0 hex 12 is sent before the byte 0 hex 34. The function code is 1 byte and tells the server what the message is for. Function codes are integer values ranging from 1 to 255, with the range 128 to 255 reserved for exception responses. 4. Modbus communication process. The client sends a request via a Protocol Data Unit, PDU, which includes a function code and a data request. PDU equals function code plus data request. Upon receiving the request, the server parses the PDU to extract the function code and data field, and then performs the action based on the function code. If there are no errors, the server responds with a PDU equals function code plus data response to the client. If an error occurs, the server responds with a PDU equals exception function code plus exception code to the client. The client accepts the server's response, concluding the communication process. After a Modbus client sends a request, one of the following four outcomes may occur. 1. If the server successfully receives and executes the request, it will return a normal response. 2. If there is a communication channel error and the server cannot receive the request, it will not respond to the client at all. The client will then encounter a request timeout error. 3. If the server receives the request but detects an error on the communication channel, such as parity bit, parity check, or cyclic redundancy check, it will not respond to the client. The client will experience a request timeout error. 4. If the server receives the request but cannot execute it, for example, the client requests to read a non-existent register, the server will return an exception response, MB except RSP2, to the client to indicate the nature of the error. As shown in the Modbus data model, the Modbus data model includes coils, discrete inputs, input registers, and holding registers. Coils are readable and writable digital outputs. Discrete inputs are read-only digital inputs. For instance, in an automated storage and retrieval system, limit switches are connected to remote I/O modules. By reading the discrete input data, the status of these limit switches can be obtained. Input registers are read-only 16-bit data. Holding registers are readable and writable 16-bit data. For example, an RFID reader and writer that supports Modbus communication can update the data in an RFID tag by writing to a holding register, and obtain the data in the RFID tag by reading the holding register. Modbus defines 3 types of function codes: public, user-defined, and reserved. For reference, see the Modbus function code distribution. Reserved function codes are used by some companies for legacy products and are not available for public use. User-defined function codes are reserved for user-defined functions. Modbus provides 2 value ranges for user-defined function codes: 65 to 72 and 100 to 110. Function code 2 is used to read discrete inputs from the server. Function code 1 is used to read single or multiple coils. Function code 5 is used to write a single coil. Function code 15 is used to write multiple coils. Function code 4 is used to read input registers. Function code 3 is used to read multiple holding registers. Function code 6 is used to write a single holding register. Function code 16 is used to write multiple holding registers. For other function codes, refer to the Modbus public function code table. 5. Summary and review. In this lesson, we learned about the underlying communication methods of Modbus, the communication process between clients and servers in Modbus, the structure of a Modbus frame, the Modbus data model, Modbus function codes. That's all for this lesson. See you next time.